Okay, doing lesson 34, talking about decimal numbers on the number line. Um, the book says, as far as the new concept goes, if the distance between consecutive whole numbers on a number line is divided by tick marks into 10 equal units, then numbers corresponding to these marks can be named using decimal numbers with one decimal place. So if each centimeter on a centimeter scale is divided into 10 equal parts, then each part is 1 millimeter long. And what they're saying there is this then. Hang on. Nice big mark. We have a 0 here. This is a centimeter marker here. And this is the beginning of 1 centimeter. This is the next centimeter. And they're saying that it's in between 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Should be 10 marks here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, we're good. And what you want to do, so you don't get confused, you want to have 10 spaces. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's how you can always make. I like counting spaces better than lines myself. But what they're saying to us is that if this is 1 centimeter, then within that 1 centimeter there is 10 millimeters. So 10 millimeters is equal to or the same thing as 1 centimeter. That's what it's telling us. So it wants us to find the length of, now it's giving us something a little bit different. Let me take my pen and change my pen a little bit here. Now it's taking something here, and this is a centimeter ruler. So we're going to pretend like this is 0, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 3. This would be 3, because this is a centimeter stick or centimeter ruler. This is 1 centimeter. This is 2 centimeters. And this is 3 centimeters. So we know in between the centimeters are millimeters, right? And we know that there are 10 millimeters between each centimeter. Okay, so we have 10 there. We have 10 here. And we would then also have 10 centimeters over here. So between this spot right here and this spot right here at the end, how many millimeters do we have? I'm sorry, I said millimeter. This should be millimeters. Okay, how many? Yes, Jamie. 30. Absolutely right. Now what the book is showing us is that this line that is being measured is stopping. I'll change my color again. This line is stopping right about here. So how would we, it wants us to know how would we read that in centimeters, Nick? Centimeters. Yeah, exactly right. 2.3 centimeters. And then how many millimeters would that be, Hunter? 23 millimeters, because we know that each one of these is 10. So there's 10, there's 20, 1, 2, 3. Because these little marks right here are all millimeter marks. Okay? Make sense? Okay, good. All right. Let me get rid of that. Okay, so our next problem is we're going to have this. We're going to have a rectangle. And that rectangle is going to be 7 centimeters here. 12 centimeters in its length and width maybe. Wants us to find the perimeter. And how do we find perimeter? What do we do? Josh? We do. So if it's 12 on this side, it's got to be 12 opposite it, right? If it's 7 here, it's got to be 7 to the opposite. So now I'm taking these numbers and I'm adding them up. I'm simply adding 12, 12, 7, and 7. And when I add those up, what do I get? Anybody? Oh, and this is centimeters, by the way. Okay, how many? What do I get? Will? how many? 38. I get 38. So I have 38 centimeters, but here's the question. It wants to know how many meters is that? How many meters is that? Well, 0.38. 0.38. Because I know that, look at, I have to have 100 centimeters to equal 1 meter, right? So if I have 38 centimeters, do I have a meter? I have to have 100, don't I? So I'm going to have a fraction. And that fraction would be, over here, it would be 38 over 100. And the way I go from a fraction to a decimal is I see that I'm using the hundredths, right? So I have to go over two places, 1, 2, and that equals 0.38. And there's my two places that I moved from the 100. When you have a number with two digits, it's going to be over 100. If I had a number with one, if that was just 3, it would be over 10, right? If I had 38, it would be over 100. If I had, up on top here, if I had 351, it'd be over 1,000. Okay? Because this would be point, and I get rid of that fraction, make it a decimal, it'd be 0.351. And it would be, and the way I would call that would be 351 thousandths. This is 38 hundredths. This is 3 tenths. Okay, so now all that is because I had 38 centimeters, but I know that it would take 100 centimeters to make 1 meter. So I don't have a meter. And I know that 100 centimeters is 100, obviously 100 centimeters, and I would put a 38 above that because I have 38 centimeters out of a possible 100. I can get rid of the 100 by just making it a decimal, 0.38. Does that make sense? Kinda? Everybody okay with that? Anybody say no? Who said they don't understand? Jamie, what's up? Okay, we're on to example 3. Wants us to find the number on the number line indicated by each arrow. I'm going to get back to recording. We're back on. It might be a black screen for a few minutes. I don't know why it does that, but it does. So listen, example 3, the last one you can look at by yourself there. You should be able to figure out that it's 4.73. Example 4 wants you to arrange the decimal numbers in order from least to greatest. Listen, guys, it's pretty simple. We have 4.5, we have 4.25, and we have 4.81. Obviously, they all begin with 4, so they're all even up till now. The next number is a 5, a 2, or an 8. The 8 obviously is larger. And it wants us to put these in the least to greatest. So the greatest is going to be 4.81. Next is 4.5 or 4.2, which is greater, 4.5. So that'll be here. And then 4.25 is obviously the least number. So this is least to greatest. That's how we do it. Okay with that? All right. Oh, no. Always the first number. All right, hey, look at lesson 35. We got about 10 minutes of recording time, so we want to get through this. Now we're talking about adding, subtracting, dividing, or multiplying decimal numbers. And the book gives us this problem. It says we have 3.6 plus 0.36 plus 36. Let me erase this decimal right there. Alright. I'm going to show you how we do this, guys. We're going to take our 3.6 and put it in a column. Take our 0.36, keep our decimals lined up, and then we have 36. 36, you would agree, is the same thing as saying 3 points or 36 point, right? You understand that? So now look at what I want to do. All these empty spaces that I have, all these spaces that I have, I want to fill them up. I'm going to fill them up with zeros. Josh and Jake, fill out your green forms for me right now. Because you're talking. Don't tell me you're not talking. Don't even tell me you're not talking. Just sign your green forms, fill them out for me, and just leave it at that, or there'll be more. Okay? You were talking. I asked you not to. And just fill them out for me. So, hey guys, we got to continue. We're running out of time. 3.60, 0.36. The columns are filled already. 36 point. I'm going to put a 0 here and a 0 here. I'm also going to put a 0 here and a 0 here. That gives me 3 columns with numbers in all my rows, all my columns, so I'm not confusing myself. At least I shouldn't be. And I'm simply going to add the columns up. I have a 6 there, I have a 9 here, my decimal stays in place, a 6 and 3 is 9, and I have my 3. Everybody see that? Real simple, right? 39.96, that's how easy it is. Alright, we're going to go on to example 2. Any questions on that, by the way? Any questions on that? That was pretty easy, wasn't it? Alright. This is another one that I think should be pretty easy, but you never know. What's easy for one person isn't always easy for another. Look at, we have 0.3 meters. We have 0.2 meters. Jacob, your hand's been up for a while. What's up, buddy? Oh, for this one? Okay, what is it? Okay, great. You want to explain to me how that is? Okay, so you're saying I'm going to take 0.3 meters, I'm going to add to that 0.3 meters, plus 0.2 meters, plus 0.2 meters, and I'm adding all these up, and you say I get, when I add this up, I get 10, don't I? 10 meters? The decimal right there, beautiful, perfect. I get 1.0 meter. And if you put 10 meters, you're looking back, how should you know that's not the right answer? Huh? No, I didn't.